Hello friends! I have often received dubious Amiga computers, and I always like to test resistance on the power rails in case there is an internal short somewhere. I do not wish to blow a power supply, or worse, because a motherboard has a shorted capacitor or someone blobbed some solder somewhere they shouldn't have. So I came up with the idea of having a power supply with fused outputs, to save myself the trouble of having to test for shorts before I power the device on for the first time. While I'm at it, I may as well put LED indicators on the outputs to indicate which rail might have an issue. So join me on my journey to create the ultimate testing power supply for the integrated keyboard models of the Amiga computer. And by the way, this video is intended for entertainment purposes and in no way is supposed to be an instruction video. In other words, don't try this at home. If you do, I cannot be held responsible for any injury or damages.
Okay, it's definitely shorted. Let's plug it in. Hopefully nothing will happen and I'll know.
Okay, so here we have a Amiga 500 power supply. The model number is 312503-016121. I don't know how many of those digits are significant, but this is a 220 power supply, and I'm in North America, so we need 110 here. So what I've already done is I've already cut the cables off of it. So here's the cable that goes to the Amiga. You know, it's got the many wires, and here's the mains or AC plug wire. If you've watched my other video, what I like to do is I like to put a modular plug in for the AC side, and I also like to replace the guts with, because this actually is broken, it has runaway voltage. I like to replace it with a Meanwell, and the Meanwell model here is the PT65B. And I've done other videos on this, and I think the video I did had a case where these posts were in the bottom of the case, if I'm not mistaken. Well, they might have been in the top, but either way, this Meanwell wouldn't fit directly in between these. I had to put it at an angle. So this is a case that's actually a lot easier because the Meanwell fits pretty much just in between those. So that means that all I needed to do was make brackets, 3D printed brackets. These are up on Thingiverse in case you want them. So I don't have a tripod at the moment, so let me screw these brackets onto the Meanwell power supply and I'll show you how it fits in there. Okay, so here we have the brackets on there. Now, after I made these brackets, I said, gee, I'll bet somebody else has done this before, and sure enough, there's one or two other designs. Nobody's using a two-piece design though, which surprises me. They're printing the whole thing. One guy has an open area and it has like an X for bracing, but really, I mean, as long as you gusset it a little bit, you know, put some vertical bracing along here, the thing is pretty solid and uses a lot less materials to just print two pieces rather than all the parts in the middle. So I went ahead and uploaded this, but you know, honestly, I can say that I didn't copy anybody else's design because I did it before. Now these holes, I made everything a little bit bigger. Well, I should say the holes for the Meanwell to put these black screws in are smaller than the holes in the Meanwell. So that means you can loosen these screws and make some adjustments. And also the holes here for the case are just a little bit loose. So what I've done there is I loosened the screw and it popped right in there. It didn't fit right away. So that should do it. It was important to measure the thickness of the old power supply PCB and match that here so that the top of the case goes on and it isn't loose or tight, and also the Meanwell doesn't wiggle around in there once you have it tight. And you can actually close it all the way, which means I didn't get them too thick. So anyway, what I like to do is I like to put a modular plug on the AC side. This is actually going to go around the other way, like this. Right? Because this goes on this side. And we're going to preserve everything we can on the outside, like the switch. Switch goes there in the top. So this little hole notch here was for the other power, was for the power cord to come out, and it was an integrated cord. It wasn't just, you know, modular like this. So it's great to have this on there, because then I can have cords of different length, and if the cord gets damaged in any way, like the posts get bent or somebody rips the ground off, it'll still, we can just replace the cord easy without getting into it. So all of the outputs on the mean well are here, and we have all our wires here, so we should be able to reach. I'm just going to solder them right on there. I could get one of these connectors, but I don't have one right now, and I'd rather not wait for one to get here and figure out what exactly the size is. If I went on and looked at the spec sheet of this, I could find the exact size. It would be pretty easy. But I'm going to go ahead and just solder it on there with heat shrink. So I'm going to put pieces of heat shrink that are just a little bit bigger than these on each one of these wires. Well, the ones that I need. Because there should be only a ground, +5, a ground, a +5, a +12, and a -12. That should be all I need. There's a shield there too. One of these is probably a shield. And I guess I could connect it with the ground, but I don't know. I forget what I did last time, but I actually have the notes on it that I took. Let's see. Yeah, right here. I just took this. This is all I needed right here. So here's our IEC connector. It's marked too anyway. It's the back of the connector. I see an N right down here. And there's probably nothing over here, but that's okay. The neutral, you know, the neutral's there. This is the hot or load. And this is the ground in the middle, of course. So this is all fitted and everything. So the next thing I want to do is just fit all the other components I want to get in there. So I'm going to put this in here too. And another thing we're putting in this video that we didn't have in the other video is, besides this different kind of case, is I'm going to put 3 LEDs next to the power switch for the 3 different voltages, for the +5, the +12, and the -12. Not sure how I'm going to do that yet. We'll figure it out. So I just need to put 3mm holes in for LEDs and wire them up to the outputs in parallel with this. Pretty simple. Of course, with the appropriate sized resistor. So for 12 volts, for example, I'll probably use a 1K. You know, and for 5, what, 220? Something like that. Okay, so pretty sure what I did before was I squeezed it into this corner. This has mounting ears on it, but I don't want to use that because basically it's designed to either go on the surface like this and have screws go through. You know, that wouldn't be too bad, except that I wouldn't be able to bury it into this corner. I have a clearance problem with the fuse right here. So I'd like to, and I'd like to, obviously I got to use the existing hole because I don't want to create a new one. So the last time I did this, what I did was I cut these ears off, and then I used the outside frame of this to hold it in this way. And then I used a piece of plastic that goes around the outside of this, epoxied on the inside, to hold it in from popping out like this, so that it only slides up, you know, like when you open up the case. So I think that's what I'm going to do again. You can see I can clear the, I can clear the fuse pretty easily. And if I come down far enough, I could even spin it upside down. I'm fairly certain I can get that to work. It does come like next to the fuse, so, but yeah, I'm going to push it this way as far as it'll go. Well, I can't go beyond this, so it's going to be right here, and that gives me just enough. I'll have heat shrink over this, and there'll be a few millimeters of space between that and the side of the fuse. And on a circuit board, you'd be lucky to have that in a lot of cases. Uh-oh. Yeah. I messed up. I forgot to account for this. Wow. How am I going to fix this one? I'd really like to, I could just cut this off and it would probably be fine. 3 screws holding it together. But frankly, I think I'd rather move this Now we're dealing with clearances that are a little closer, but I do have a few millimeters before I start to get into that that fuse, hitting that fuse. So, and we're already really close. We do have that gap there, as you can see. We're already really close. We're only like a millimeter off. So if we open this, if we cut this down a millimeter in this direction, this will fit this way. It'll clear the innards here. I can even bring it down a little bit. And then so basically the best way to deal with this is to make it seem like this space here that's going to be opened up is sort of part of this. So that just means a piece of black plastic back here. Yeah, something like that. Now I have to decide whether I want it to be behind it, flush with the case plastic, or on top of it. I actually think on top of it would be the easiest, because then I'm still not having to deal with finishing off this edge here. I just need to create a piece of plastic that goes over. So what I'm going to do is I'm going to go ahead and go forward with that, because I mean all of my other clearances are fine. I'm going to go cut down a little bit so this sinks down. I can go ahead and this was going to be flush and the lid was just going to pop on. Now we're not going to be able to go down all the way, because then we'll be hitting the fuse, or we'll be too close to it anyway. So, but I can come down a little bit. I guess what I should do is go ahead and come up with my game plan for covering this hole first before I go too far. So that means getting another piece of plastic. So, and I'll bet you when we're done with everything, when it's all said and done, we won't be too upset about it. Okay, end result. Shouldn't look too bad. I went ahead and, I mean, as long as I was doing that, I may as well have put the inside, you know, inside the case design to hold it in place. So this piece right here and this piece over here, first I super glued them in and then I hot melted them in. Epoxied them in. Because when people pull on the cord to yank it out, you know, you have to just be aware. So that's the end result. It looks pretty good, I think. It's time to carve this out to match. I'll do that right now with my Dremel and my hobby knife and my files. Okay, so I've hollowed out the case as needed. You start with the big coarse tools, and you just work your way down. Maybe you use a coarser file and then a finer file. You switch from cutting with this to cutting with this, and eventually you get something like this. So we're good there. What I'd like to do, this is going to be my primary power supply that I'm going to use. And so I've decided that not only am I going to put 3 LEDs for the 3 voltages, I'm going to put fuses inside for the 3 voltages. And so I could basically stop having to take the time to test for shorts. I can use this as my short tester. So I'll wire the fuse in on the output of the secondary side, the lower, the 5, the plus 12, and the minus 12. Wire it straight into here, the 3 fuses into those 3 outputs. Then I'll bring it through the fuses, then out to the lights and to the output of the Amiga. And that way, when a fuse blows, the light will go out as well. It'll cause the light to not make connection anymore. So that should work out pretty well. I'll know which rail is shorted, which, without having to open this up. Basically what I did is I mounted those, I made some mounts. I 3D printed some mounts for the mean well. But I decided to do on offset, so I've made different mounts that give me room up here, and I want to probably put fuses down there. So this thing lifts right out the way it is, and I don't really want to sacrifice that, so I almost want to maybe just glue an extra piece of plastic. This is some scrap plastic I have. An extra piece of plastic across here, maybe with a foot that comes down or something in the middle, and then attach, cut this out and attach it onto there. And then, because it's going to be tricky as far as routing wires, because let's see if I can do this sort of, yeah, because I need to come from the output into the fuse, and then on the other side of the fuse I need to come out. One side's going to go to an LED, and the other side's going to come to the output cable. A split. So we're splitting on this side to go to the LED. So we have 3 LEDs, we have 3 outputs, we have 3 fuses, and the 3 outputs are here from the actual power supply. So yeah, I can make this work. It's just going to have a few extra wires inside, but it'll be real nice if I can make it so that the whole chassis lifts out. I kind of wish the switch was not in the lid. The switch is actually located in the lid, and that's where I put the lights. I mean, that's a logical place for you to have the lights. But what we have now is a situation where when we lift the top off of this, we're going to have the wires attached. The switch just pops out. So you lift the top out and the switch just kind of basically falls out. It's not an issue, but the LEDs, you know, if I knew I was going to do it this way with fuses and everything, I may have I may have rethought where I put the LED. It just seems like the most logical place to put them, by the power switch. So, I mean, that's definitely the side that you're going to have facing toward you, so you can push the switch, right? So it definitely should be on this side anyway. Putting it next to the switch seems logical. You know, maybe, yeah, I probably would have put them down here. Would have been a better place, because then I wouldn't have to be worrying about what I'm going to do about wires that are going to be. So I got two choices. I can either just hardwire them to the fuse board, you know, in the bottom, and then just leave enough slack and be able to do this or whatever. The other idea I could do would be to have a, you know, like connectors that you can just pull off. That seems more trouble than it's worth, though. But I have been using filament, clear filament, to pass light out to other areas. I've been using that in various projects over time, and I don't know if I have 3mm, but I know I have like 1mm. But the idea there being that we just have the filament attached to the top that runs to a place where an LED is, and then that way when it's down, the LED shines through it. It's a way to disconnect the top from the wiring and just use a light pipe, basically. So I have to think about how I can do that. That would be really cool if I could do that, because then I could just pop the lid off and I just have the filament in here. I wouldn't have the LEDs. I really, really wish I had put the holes down here, but you know, they're there. It's cool to have them next to the switch, so we'll deal with it the way we dealt with the issue with making that hole accidentally too big. Okay, so here's my final design for at least the fuse and LED part. I'm still not sure how well the LEDs will work. There's one here, and one here, right next to the fuse. It's a really convenient place to put them rather than run some kind of wire back and forth. So each one of the power rails on the output of the power supply, each of the different voltages comes out. So like for instance, this first one is 5 volts. So it's coming out of the output and it's going into the left side. So the left side of these fuses is coming straight from the power supply output. And of course the fuse is a series fuse. It bridges over, and then the output of that, to the output of that, I'm going to solder the cable that goes to the Amiga. It's going to be soldered on that side. The LED is there as well, so they're going to share the output. And so that's going to be, you know, one of the rails, and this is going to be another one. So I'm going to run wires from the cable that comes from the Amiga, one here, one here, one here, and then one ground. It's pretty much all you need. And then for the ground side of the LEDs, you know, the minus the cathode, I've affixed a resistor of appropriate size. I use a 220, or was it a 200? I think it was a 200 ohm resistor for the 5 volt, and then a 1K for the plus 12 and a 1K for the minus 12. And the only difference between the plus 12 and the minus 12 is that on the minus 12, the LED is just turned opposite. It's 180 degrees, because the negative part, you know, the negative common output from this power supply becomes the higher voltage, because minus 12 is negative 12. So if you go from negative 12 to 0, you know, or ground or common or whatever it is, then that is 12 volts going positive from the negative to the 0. So that means you just need to reverse the LED and stick it in there and it'll work. So these are both 1K resistors for that. I had some trouble figuring out how to do the ground, but the ground is kind of hidden. It goes underneath, and that's where the connection is for those. So yeah, the only thing I've tested this. In fact, I'll show you. Plugging it in here. So Turn it on, and we have our three output colors. Okay, so red is going to be 5 volts, white is plus 12, and blue is minus 12. So we know everything's working there, and so all we need to do is hook the cable, the output cable up. Okay, so sorry for the background noise. So this is the completed power supply. It's in regards to all the internal wiring and functionality of it. The only thing I want to do is hopefully try to find a way to get those 3 lights to extend out that side of the top of the case. So I'm going to work on that next. But the very next thing I need to do, we have no shorts because we got 3 LEDs, is I need to verify the voltage. Yeah, like that. And I wrote the colors down for a previous project, and they seem to be the same on this new cable, but I did not trust it. I went ahead and verified that, 12 brown was this one and black was, etc. So anyway, and the only other thing that I didn't mention is that there's a shield. The shield that goes around the outside of the connector is yellow, and it's literally a shield that runs down the inside of this, so it's bare wires as it exits the jacket. But so I just removed the yellow wire and replaced it with this black one and ran it over to the earth ground. That's the way the old power supply was, so I replicated that, for safety, having a ground. So now I just need to test this on the connector and make sure the connector needs cleaning too. And just verify that it matches that before I test it. Always a good idea. So I have it hooked up to an Amiga 500 test motherboard, and I have just a GoTech to test whether it works. And the GoTech screen was dim, and I noticed that the 5-volt fuse was glowing, and the little filament in the fuse was glowing. I picked the smallest fuses for this, and that's probably not necessary. I picked 0.1 amp fuses at 250 volts. So I'm going to switch to something 10 times, because what we're really protecting against is a short. And there's no question that 1 amp fuses are going to blow. They're 1 amp 250 volts, so you got to understand with Ohm's law that's a lot more. But it's going to be, if there's a short, these should still blow, but we won't have any problems with current. So I'm going to replace these fuses real quick and test it. All right, so let's try this again. Okay. Yeah, that's better. And who knows, I might need some larger fuses. I haven't done the calculation with Ohm's law, but it seems like 1 amp fuses at 250 volts should be fine. And they're fast blow fuses, so they'll really help to protect any Amigas that I plug into it that may have an internal short on the power rail. So the only thing I have left, this works perfectly. The only thing I have left to do is somehow extend the lights to the outside. I mean, I could just put the cover on, and there's slats in the cover, but you won't really be able to determine if any colors are working or blown out or whatever. It's just going to come out as one color probably, or yeah. So this is going to be the toughest part, actually. This so far it's been pretty easy. So yeah, it worked out okay. Let me take the cover off. Hopefully I can do this without. So there we have our LEDs, and here we have our light pipes. I stabilized them with epoxy and a piece of plastic. So their relative positions secured together pretty much successfully secures them to where they are. They move as a group. So there's only one problem with the situation. You know, when I go to replace a fuse or something and I bump one of the LEDs, it's going to be off and it won't light as bright on the lights. But obviously there's a quick fix for that. But I mean, it's not like I can reach in here with my hands anyway, so I'll be using needle nose pliers, which is very common for being able to replace fuses. They make fuse tools. In fact, I think one of my cars has a little fuse tool that you can grab fuses with. It'd be handy to have one of those around, or 3D print one. Really, I can probably do that. Anyway, so let me put this together and we'll check it out for the final test. Okay, so here we are with our power supply and a working Amiga 1200. That's an error because the ROMs that I have in here don't match the workbench that I have there, so that's why there's an error and it doesn't boot up all the way. But everything seems to be working fine. So yeah, we're done with our test Amiga power supply. I'm going to hang on to that one. Anyway, thanks for watching.